Hi, today we are going to discuss optimum value problems. So our target today is to minimize the cost of a cylinder, which we are given the volume of the cylinder, the material cost for the wall top and bottom. So the first step is we need to find a function that will minimize the cost. So the surface area for the cylinder is, we will have for the top, bottom and for the wall. So we got pi r square plus pi r square and then plus 2 pi r h. So we got 2 pi r square plus 2 pi r h, which is 2 pi r square is for the top and bottom and 2 pi r h is for the wall. And then we need to find the height, from the volume of the cylinder. Pi r square, h equals to 8, and then we got the value of h, which is 8 over pi r square, and then we need to substitute into the formula, into the function. So we got 2 pi r square plus 2 pi r times 8 over pi r square, and then we got 2 pi r square plus 16 over r. And then we got the cost. The cost for the top and bottom is 3, so 2 pi r square times 3, and then the cost for the material for the wall is 2, so 16 over r times 2, so we got the cost is 6 pi r square plus 32 r power of -1. And then step number 2, we go to the step number 2. We need to differentiate the cost with respect to r. So we got 6 pi times 2r plus 32 times negative r power of -2. We differentiate the cost, and then we got 12 pi r minus 32 over r square. And then we need to find the values of r, so we go to the step number 3, which is we equal the dc over dr equals to 0. So we got the values of r. So here we equal to 0, and then we find the values of r. So the value of r, we will get the value of r is equals to 0.947, right? And the next, when r equals to 0.947, we will get the value of h. We substitute into the formula of h. And then we got 2.84 centimeter, and then we substitute the value of r and h into the formula of cost. And then we got the cost for the cylinder is 50.7, right? And then next is we need to find whether the cost is maximum or minimum. So we use the second derivative test. We need to differentiate again the dc over dr. So dc over dr, here we got 12 pi r minus 32 r power of -1, and then the second derivative d2c dr2 is equals to 12 pi plus 64 over r cubed, right? And then we need to check whether the second derivative is greater or less than 0. So we substitute the value of r, 0.947, into the second derivative. And then we got the value of the second derivative is 113.057, which is greater than 0, so it is minimum. And the last one is the conclusion. So we can conclude that the cost is minimum when r is equals to 0.947 and h equals to 2.84 centimeters. So we got the dimension for the cylindrical container, right?